Good morning, students. Today we'll do uh, exercise 7.10 of mathematics chapter integration, HS2ndyr science. So let us start this exercise. So in this exercise, first question is like that: 7.10 integration 0 to 1 x by x square plus 1 dx. Here clearly we can say numerator is the differentiation of denominator. So since numerator is differentiation of denominator, we can write, either you can put here, if I give half, then it will be twice x. Numerator is differentiation of denominator, so no problem, directly we can write log half log x square plus 1. Or we can substitute, let x square plus 1 is equal to y, so twice x dx is equal to dy. So we can write x dx as dy by 2. Now for x is equal to 0, y will be equal to, if we put 0, y is 1. For x is equal to 1, y will be 2. So we can change these things from 1 to 2 half. It is x dx is dy by 2, so dy, we have taken this outside, so it is this. So half log y, and range is from 1 to 2. So if we put 2, log 2 minus log 1 to 0, so our answer is half log 2. So this is the answer of question number 1. Now students, question number 2, integration 0 to 90 and root sine phi into cos phi d phi. Here, see what we can put here for this one. For that, what substitution we will do? If I write sine phi as y, then its differentiation will be cos phi d phi is equal to dy. So for phi is equal to 0, y will also give 0 because sine 0 is 0. For phi is equal to 90, y will be what? Sine 90 is 1. So our values now changes into 0 to 1. This is root y. Now cos to the power 5y, cos to the power 4y, cos to the power 4 phi into cos phi. Now cos to the power 4 phi we can write as 1 minus sine square phi, sine square to y square whole thing square, and cos phi d phi is our dy. So you see that this is the thing. Now if we break and multiply, this is a minus b whole thing square, and that will be multiplied by root y. So root y minus 2 y square and half. So it will be 5 by 2, y to the power 5 by 2. Here also for our convenience we will be better to write this one. Here it will be y to the power 4 into root y will give plus y to the power 9 by 2. Of course it is, you just see, y to the power 4 plus half, it will give what? Power as 9 by 2. So these things is there. Now this one we can write this as y to the power 3 by 2, twice y to the power 7 by 2, y to the power 11 by 2, and whole thing we will take 0 to 1. Now if we put 1, then we get value, but if we put minus of this 0, then 0 will vanish. So if we put 1, it is 2 by 3. If we put 1 here, then it is 4 by 7, because this term 1, 2 will go above and it is 4 by 7. If we put 1, then it is 2 by 11. Minus, if we put y as 0, all will be 0. Now, this thing will be what? 21 into 11 is 3, 2. So 231 is in the denominator, and numerator, after calculation of this one, we get numerator as 64. So our answer is 64 divided by 231. So this is the thing. So we have completed our question number 2. Now we will do question number 3. In question number 3, it is written as like that: integration 0 to 1 sine inverse twice x by 1 plus x square. Students, this is the formula of what? This is, if we write this one, then it will give as, if we put x as tan theta, it is the clue what we have to put here. That is, no formula is there, that is idea we can get from this clue, that let x is equal to tan theta. Then dx will be what? Sec square theta d theta. For x is equal to 0, if we put x equal to 0 here, then theta will be changed into 0. For x equal to 1, theta will be what? Pi by 4. You see, if we put 1, then pi by 4 will only give this value. So ultimately we get our value as 0 to pi by 4. Here sine inverse 2 tan theta by 1 plus tan square theta. And dx can be written as sec square theta d theta. 0 to pi by 4. This one is actually sine twice theta. So this will cancel with here this sine, and we will get as 2 theta sec square theta d theta. Now integration by parts, taking this one as first function, that one as second function. So twice, it will be outside. Theta, integration of sec square theta is tan theta minus integration. Differentiation of theta with respect to theta is 1. Integration of sec square theta is tan theta d theta. Whole thing under the range 0 to pi by 4. 2 theta tan theta. If we put here pi by 4, then pi by 4 into 10 pi by 4, that is 1. And if we put 0, then to 0. So it is twice this one, 2. Now integration of tan theta is log modulus sec theta. Now it is 0 to pi by 4. 2, it is pi by 2. If we put pi by 4, sec pi by 4 is root 2. So we will get log root 2. If we put 0, sec 0 is 1, log 1 to 0. So we achieve this value as our question number 3. Now question number 4. 4 is like that. Better to clean this one. Here 4 is 4 integration 0 to 2x root over x plus 2 dx. Student, here you see that what we can put here for getting this answer. My solution, you put x plus 2 as y square. If we put y square, then differentiation dx will be twice y dy. For x is equal to 0, y is of course root 2. If we put 0, then 2 root 2. For x is equal to 2, y is definitely 2. 2, if we put 2 plus 2, 4, y square 4 means y is 2. So we can get now root 2, 2. X is here, y square minus 2. x plus 2 is y, dx is twice y dy. So we achieve this one as our up to this after substitution. Now y to the power 4 minus 2y square dy is this one. Then we will get, after integration, y to the power 5 by 5. This is 2 y cube by 3. Whole thing, it is root 2 and it is 2. If we put 2 here, then it is 2. Inside bracket, 2 to the power 5 is 32 by 5. Here, if we put 2, it is 16 to the by 3. Minus, if we put root 2, then here it will be 2 to the power 5 by 2 by 5 plus, if we put root 2 here, then it is twice 2 into, and 2 to the power half means 3 by 2, 3 by 2 plus 1, 5 by 2 by 3. So we think after calculation we will get these values as 32 by, these two will get 32 by 15, and these two if we add, then this will give 16 root 2 by 15. So with that we end our question number 5. 4 we have finished. Now we will do question number 5. Just simply substitution and then not so tough it is. So try to understand this one. Now 5, it is integration 0 to 90 and it is sin x divided by 1 plus cos square x dx. Now here what to substitute? If we take like cos x as y, then its differentiation is minus sin x dx is equal to dy. So sin x dx is minus dy. For x is equal to 0, y becomes 1. For x is equal to 90. Yes, I think it is 90. Then it will be, y will be cos 90 to 0. So what we get? That is our limit is 0 to 1 to 0 instead of 0 to pi by 2. Sin x dx will give minus dy, and here 1 plus y square. Clearly it is a value of tan inverse y minus tan inverse y. 1 to 0. If we put 0, then it is the 0. If we put 1, tan inverse 1 is pi by 4, minus minus will give only plus pi by 4. Student, I have skipped little bit, that is calculation, only to get the answer. So any doubt in anywhere, you will ask the thing that I have problem on that one. Definitely I will make it clear. Now question number 6. We are little bit hurry we are doing because we have to finish all the sum of the exercise. That's why I am doing question number 6. It is 0 to 2 and dx divided by x plus 4 minus x square. Now how to do this one? If we try to do by, that is x plus 4 minus x square, what we can write? 4, better you take minus common. Then x can be written as 2x half. Here you write 1 by 2 square. Minus half square, it will give a plus. What we get? These two if we combine, 4 4 jar 16, 16 plus 1 17 by 4, and this one is x minus half whole thing square. So if we put here, then it is 0 to 2 root 17 by 2 whole thing square minus x minus half whole thing square. So what we get? It is one formula, integration dx by s square minus x square. So formula according to that it is 1 by twice a root 17 by 2 log modulus a plus x root 17 by 2 plus x minus half divided by a minus x root 17 by 2 minus x plus half. Whole thing you have to give the limit 0 to 2. These two cancel, we will get root 17. Here, if we put 2, then one value we will get. If we put 0, then another value we will get. And ultimately, by putting this and calculation, if we little bit skip, then it will be as root of log 21 plus 5 root 17 by 4 after rationalization also. But if you keep here after calculation this one, no problem, you can do up to this one. So students, we have finished up to this one. So I expect that you will try the remaining sum of this one. And now give your attendance in your comment box. That much for today.